So I got this board here. This is out of a 70-inch Sony. This is a KD 70x690E. And the problem with this board is that it's dead, right? The TV was dead. Well, the actual television is dead. There's no lights, no nothing at the bottom. And on this board here, we are not getting any standby voltage. All right, and the standby voltage on here should be exactly 5 volts. If we look at our legend right here, if we can see pin number 1 is 5 volt standby, and I have absolutely nothing. On the grounded here, I'm going to go to pin number 1. There is absolutely nothing. Now, it doesn't matter what order you do this in. We're actually going to unplug the board, put my meter in continuity. The next thing I'm going to check is the actual fuse. My meter in beep mode. Fuse is good. TV is unplugged. Reminder, if you're working on boards like this, make sure that you're using a isolation transformer. Right there where the yellow cord is. Okay, it's plugged into my isolation transformer. That way you have less risk of getting shocked and or damaging the board by, putting your meter leads in the wrong place. So I don't have any, my fuse is good, but I don't have any standby. So what I'm going to do is plug it back in. My meter on DC volts. And plug it back in. And I'm going to check the voltage across my big filter capacitors. I only need to check one because they are in series or parallel, one of those, but they should all have the same voltage if it has any voltage on it, and make sure that's not fluctuating. Oh, hold on for a second, what's going down? Volts DC. There we go. 165 volts. Make sure you can see that. And it is fluctuating a little bit. See, they're going from 165 to 164, 163. So the next thing I'm going to do is I'm going to find out where my standby transformer is, or our standby circuit that's producing our standby on the secondary side. So in most cases, on most power supply boards, you're going to have more than one transformer. Now, obviously, from looking at this switching transformer is going to be for one of these diodes or these diodes, and it's probably going to be for our LED circuit or LED voltage. Here's our plug for our LEDs, and obviously, the smaller transformer is producing our standby voltage. So, and we have to look and see what's driving it. So, in this particular case, we have the MOSFET right here. Board's still plugged in, so be careful with touching stuff. But this is the actual PWM chip / MOSFET. Okay, closest one to the transformer, and you can always tell because there's always, this is what they call a A6000 series PWM MOSFET chip, and you're always going to have pin 6 missing, which is this pin. Where is it at? Right here. We have 5. There's no pin. Pin number 6, 7, and 8. So pin 7 and 8 are always going to be your drain pins. Okay, and pin number 1 is the source, which should be going to ground. And I actually printed out a data sheet on it. Okay, so let's look at it. Right. So this particular IC that I have on this Sony board is a STRA 6069. And you see here, so here we see pin 8 and pin 7 are both tied in together. Those are the drain pins, and that should be actually going right to the transformer. Okay. VCC, that is coming from the auxiliary winding of this same transformer right here. Okay, and that's going to produce our VCC for the IC to work. And we have a feedback here loop that is going right to the optocoupler, okay, which is monitoring, the optocoupler is actually monitoring the voltage rail or the standby voltage on the secondary side. And when it lights up, the LED lights up inside the optocoupler is going to send this IC feedback, so it knows how fast to switch this transformer, okay? And the source pin is pin number 1. Now the gate, there is no gate pin because the gate pin is inside of the IC. All right. So what I want to do now is I want to make sure that I have voltage here on pin 7 and 8. I need voltage there so that IC can actually switch that voltage on and off going through this transformer. That way we can get energy on the secondary side, the other windings in the transformer that are connected to the secondary side, and also for our VCC. So what I'm going to do is make sure that I do have voltage on pins 7 and 8. So I'm actually going to ground my meter on, still plugged in, I'm going to ground my meter on the negative side of this big bulk capacitor because we are on hot ground. So being very careful, prefer to use an alligator clip, which I might just do. Being very careful when I plug this alligator clip up, all right, that I don't short across the capacitor because you are going to see some smoke and you might damage the board. But we're going to put that on my negative black lead. My meter is in DC volts. And I want to make sure that I have that same 165 volts going across the drain of the MOSFET. Even if I'm using a regular MOSFET with a separate PWM IC, which is usually located on the bottom of the board. Let me just give you guys an example. Here's an example here. This is obviously, they're just using the one switching transformer going across the isolation line. So this is a switching transformer, and these are MOSFETs that are actually switching the 166 volts or whatever across this transformer. And above there should be a PWM IC, which is usually the one closest to the MOSFETs, and that's that one. So we'll actually check to make sure that we have, even though they got it covered up on the drain or middle pin, we should have these 166 volts. Or we're using the power factor correction circuit, which it does because I see a big inductor on the primary side. Then we should have 388 volts. But I want to make sure that we have the 165 volts right here at pin 7 and 8. Okay, 165 volts. And that is definitely fluctuating. And that is why we're not getting any standby, obviously. So next thing I want to go to is I want to go to the actual VCC pin, which is pin number 5. That's always a pin by itself on the other side. All right, maybe hopefully you can see that. Pin 5 right here. Okay, you see it says VCC voltage. That's coming up our auxiliary winding. Let's see if we even get anything over there. So let's go to pin 5 right here. And that is actually fluctuating. Okay, so that being said, that's why we are not getting any standby voltage. Now, so we don't know if the problem is on the primary side or the secondary side. So what I'm going to do before I do anything else, I'm going to unplug this. And I want to see if we are getting any voltage on the secondary side. So first of all, I'm going to take my negative lead, put it on cold ground, on the secondary side. I'm going to go across these. These are actually our diodes right here for our standby voltage. So I'm going to put my meter in DC volts. Board is still plugged in. I'm going to check and see if I have any voltage going across the cathode of these diodes. Just like in this diagram right here, right? Once the IC switches that 165 volts off and on across this transformer winding. On the secondary side of the transformer, the voltage has to be rectified, okay? And this is our same optocoupler going to the feedback circuit or feedback line of the IC, right? So this is our pins 1 and 2, if I'm not mistaken. So let me go across these diodes anyway. Go right here. Grab my meter, one of these tabs, and let's go across here. I have nothing. Absolutely nothing. Now, what I'm going to do is I'm going to go across each one of these optocouplers from between pins 1 and 2 and see if I have any voltage. If I don't have any voltage there, I'm pretty sure the problem is on the primary side. Let's see. Doesn't matter which leads you put on pins 1 and 2. It's just going to have a negative reading. Okay. So I'm actually getting a fluctuating 0.2, 0.3 volts. Okay, so that's kind of weird because I'm not getting any standby voltage on the secondary side. So how is that happening? All right, let's go to this other optocoupler. Nothing. That looks like it wants to come up. And this optocoupler here, let's go to this one. I don't have anything. And there's nothing there. That's weird. Why am I getting almost a half a volt fluctuating? Right? That one's nothing. And I'm getting the same thing here. So let's see what I can do here. I'm going to show you a little trick here. We got 5 optocouplers. One of these optocouplers is going to the feedback pin is going right to the feedback pin of this PWM chip. Even if they're using a separate chip with a separate MOSFET, go to that PWM chip and find the feedback line. All right, use a data sheet or whatever, or you can just trace it. One of these pins, one of these optocouplers is going to the feedback chip. So I believe it's pin 1. I'm sorry, on the other side. I believe it's pin 3, and the other pin 4, is going to ground. So the feedback pin is pin 4 here. Put my meter in beat mode. Of course, I already know which one it is, but I'm just going to go here. It should be the one closest to the IC. So pin 4 is on this side, right? 1, 2, 3, 4, 5, 7, 8. So 4 should be here. And meters in continuity. Here we go. Okay, so this is the optocoupler for the feedback for this IC. And the other pin on the optocoupler, that should be going right to ground. So I'm going to use hot ground, go back to this, put the capacitor. That's hot ground, okay? So none of these other optocouplers, we got one there, okay, and one here. But you want to make sure that you have the one that has the optocoupler that is going to the standby circuit or the IC that's switching the standby transformer. So what I'm going to do is, it's unplugged, okay? Thank God, right? Is I'm actually going to find the optocoupler, turn the board around. We are on the primary side. I'm going to disconnect the 2 pins on the primary side that are going right to the IC. I'm sorry, that's the secondary side. Primary side right here on this side. I'm going to find that IC, which should be right here. Right here. These 2 pins right here. I'm going to unsolder them. Hopefully I did the right one. And I'm actually going to pull it out of the circuit. All right. So now what I'm going to do is I'm going to take a diode, any kind of diode, as long as it's a rectified diode. You can use a Zener diode. Just make sure the cathode of the diode, right, the stripe part, is going to ground. We're actually going to trick the primary side, or actually going to separate the primary side from the, I'm trying to say, from the secondary, or trick the primary side into working, okay? We're basically just going to isolate where the problem is. So I'm going to actually make sure I put my cathode on my ground side. I believe that's pin 3. That's going to ground. Okay, and the other one is not. I'm going to put my diode with the cathode part going into the pin, the stripe part of the diode, going to, if you can see that, okay, let's see. The stripe part of the diode, that's going to be going to ground. Making sure it's not shorted. I don't have a solder bridge in between there. Okay. And I'm also going to double check and make sure I do have the cathode going to ground. This cathode on the diode should be going right to ground. Okay, so now that I've done that, I'm going to recheck the B plus, the 165 volts, see if that's still fluctuating, and I'm also going to check my VCC for this PWM slash MOSFET IC. And let's recheck our voltages. So I'm going to check the voltage across the bulk capacitor. That is not fluctuating. Okay? It's not fluctuating. And I'm going to check my VCC voltage for the actual IC, which is pin 5. So I'm going to ground it on the high side. Let's check out pin number 5. Look at that, 9.6 volts, and it is not fluctuating. All right, and let's even check the feedback pin 4. We have a steady 0.5 volts. So yeah, probably wouldn't be switching because we don't have any feedback. All right, so now that's a good sign that the problem is probably on the secondary side, okay? And that's why the power supply is restarted. That's why the voltages were fluctuating on the capacitors and on the actual IC. So we need to do some troubleshooting to find out what's going on here, right? So we unplug my TV, unplug my board. My meter, I'm gonna check the main components first. So I know we don't have any shorts on the primary side, because if we did, otherwise, right, we'd be getting nothing, right? So we're gonna start checking some diodes. Could be a bad capacitor. Well, let's just start with, well, it wouldn't be a bad capacitor because, especially in the standby circuit, because if it was, we should still be getting some standby voltage. It would just be low or fluctuating. It would be like 2 volts or 1.8 volts, something like that, right? So let's check these diodes here. Check the standby diodes. All right. Go right here. Check these diodes. And we have a short. Both diodes. Now you might be thinking, well, because those diodes are right off of the transformer. As a matter of fact, let's verify that. We'll put it in beat mode. Look at that. Yeah, those are reading short. Now this is our standby capacitor for our 5-volt standby. And I'm actually going to go up under here, find it. It's actually located right here. These are our diodes here, right here, here, okay? Which once again I'll show you are shorted. Now this is electrolytic capacitor right here. That definitely should not be shorted, all right? I don't care if those diodes are going across the windings in the transformer or not. That should definitely not be shorted. So what I'm gonna do is I'm gonna actually pull those diodes out. And guys, be careful when you're using solder wick. Make sure you don't have too much in the end, because especially if you're soldering something on the primary side and a piece of this wick touches something else with voltage across it, you will damage your circuit board or your circuit. So always try to use the end of your solder wick. I'm just going to place it right here, and this stuff should come right up. Here we go. These are actually Schottky diodes, so we should be getting a almost infinite one way and a pretty low reading. Won't be should be lower than 0.5 volts. So let me put my meter back in diode. Okay, we got 0.2 voltage drop across this here from cathode for 4 bias, right? And then infinite the other way, and then on this diode we'll forward bias it, put our negative lead on the cathode, the stripe part. All right, that one is shorted. Yes, that is shorted. Yes, 0.0015 is shorted. This one, infinite one way, and 0.2 voltage drop across the other way. Now let me see here, make sure the short is actually gone. I'm going to check my resistor. Where we at up here? Yep, the short is gone. All right, the meter's in diode mode. Flip it around. Okay. So those are just Schottky diodes. I've got some, actually got some some bigger ones here. Okay, these are also Schottky diodes that they use in the Vizio power supply with the, I forget which model that was. And let's just double check so we get even closer to that 0.2 volt or 4 voltage drop. So that's 0.3. The other way should be infinite, and that's 0.3. Oops, sorry. So that is 0.3, and the other way should be infinite. Okay, so those are bigger. Those shall hold up. If they'll work, they should work. They can't do any more damage, right? Well, it's either going to work or not going to work. So let's put these in. Already got the leads bit. Okay. Make sure we're going the right way. As you can see, the stripe side that's actually on the board. Right here. Going across here, that is where the cathode goes. Pretty simple, right? So I'm going to put those in there. Okay. And I do want to make sure that those resistors are, where we at? I don't know what that was, okay. It says those should be 2 ohms. They're in parallel, there should be what, 4 or? I tell you what, I forget. They're parallel, what is that? Resistors should, yeah, they should be, I'm sorry, those are 20 ohm resistors. I'm sorry, those are 20 ohm resistors, so they're reading 10 ohms. Yep. So both of those resistors should be good, because that's half. Should be 10 ohms, okay. 10 ohms. Alright. What I'm going to do now is I'm actually going to take my diode out, where I put the diode in for the output coupler. I'm going to take that out. Where are we at? Solder that back. Alright guys, so replace our dial. So let's go, first of all, let's go to, remember we have fluctuation on the bulk capacitors. Let's see what we got now. Alright. Oh, I'm sorry. I should plug it in, that might help. Okay, let's plug it in, it's plugged in. And our bulk capacitors, make sure that's not fluctuating. We are at 164 volts, and that is mighty steady. That's a good sign. So now what I'm going to do, matter of fact, let's be on the, where's my other, just going to go ahead and ground my meter so I won't keep moving it around. I don't want to arc anything. Remember, we are still on the primary side of the power supply, on this side of the line. So we're on high ground. So once again, let me go to my actual PWM MOSFET. And let's go there. I got a steady 164 volts. Now let's go to our VCC pin. That's the most important thing. Remember, that was really fluctuating. That would be pin, this has 2 dots, but obviously where the pin is missing is pin 5 right here by itself. And that is a steady 16 volts. Okay, that's a good sign. Let me go to my feedback circuit, feedback pin. and that is 0.8 volts. All right. So now the ultimate test of time. Well, let's do this first. Let's go to our. Disconnect this. Yeah, I love to live dangerously. I'm one of those. One of you power supply police. I'm gonna say you should unplug it first. Yeah, well, that's okay. I want to keep moving the video. I don't want to keep moving my head across the camera. But I'm gonna take my oscilloscope here, right, and I'm going to go to pins 7 and 8 of the actual PWM chip when that should be switching, right? So once again, I'm on hot ground. My probe is on ×10 because we are using a bigger signal. So we're going to be able to see that on the scope because we're right at the drain pin. So let's go to pins. Go to pin 8. All right, be very careful here, making sure that we are good. Okay, let's go to pin 8. There we go. We actually have a drive signal. Yep, there it is. Okay, now the ultimate test of time. Let's see if we have our 5 volts. We have it right at the cathode of these diodes. There we go. And one of these are, we can go right to the connector, make sure there's 5 volts there. There we go. 5 volt standby. Alright. So the point out of this, even though I showed you that trick, if you're getting any voltage, if you're not getting standby voltage on the secondary side or any voltage on the secondary side, and you go across these optocouplers and you're getting voltage, there's nothing there. You have to have the, that's for the power on, I believe. Turn on the power correction circuit. 1 volt across that one. Okay, that's our feedback line. But it doesn't matter because we'll still have our 5 volts. Okay, cool. So yes, if we've got no standby voltage on the secondary side, but we have voltage across these optocouplers between pins 1 and 2, then most likely we're going to have a problem on the secondary side because for some reason it is getting voltage. And so you can do the diode trick and make sure that we do have if we have steady voltage on the PWM chip for the VCC voltage, and we have a steady voltage across your main bulk capacitors, then most likely your problem is going to be on the secondary side. If it's fluctuating still after you put in the diode, or the VCC voltage is not there or whatever, then most likely your problem is going to be on the primary side. But just so you know how that works, another troubleshooting tip for you. And hey guys, if you're watching this video on YouTube, because I do upload my videos like this on my community page in my course first, before I put it on YouTube. But if you guys are watching this on YouTube and you guys want to get some more in depth, want to learn about this stuff more in depthly, guys, please do me a favor. Make sure you get the course. It will actually amaze you, right? How fast and easy this stuff is to learn, especially the way I teach it. If you don't want to join the course, that's fine. You can always get involved in our Facebook group, all right? That's actually free, okay? And a lot of our technicians that were in the course can help you if you have any questions or anything. And there are a lot of posts on there. But until then, guys, I will see you in the next one. Big Dog out.